All right, we might as well begin. Thank you for joining us and catching this video series, another episode. So far, it looks like it's episode 22. If you've stayed this long and have been watching this series through the entire boredom, I congratulate you and I appreciate you. Please like and subscribe. It definitely does help encourage me to keep the boredom coming. I've been enjoying making these. I've always wanted to teach and give back to the community my knowledge, my experiences in whatever shape, way, or form I can do. Even if it helps one person learn something new, discover something they never thought they were interested in, that's more than enough for me. Information sharing is very important in my book, in my world. I firmly believe in it. I don't believe in information islands. We should share knowledge as best as we can in whatever format we can. That's how the next generation can move forward and have a good solid foundation to build off of. So in the last video, we were doing some layout. I noticed a few things that I missed. One of them was the FTDI interface to talk to the ESP32. We're going to drop that in. And I also was doing some other digging before the stream and looking at past projects that use an RS-485 transceiver. And in past projects, I had used one that actually does operate from 3.3 volt supply. The good thing is a pin for pin drop in. It's pretty much the exact same chip, does the exact same thing, the exact same footprint, same symbol and everything. I went ahead and created all the entries, created the library entry in KiCad, created the entry in Odo, so you don't have to sit and watch the more boring part entry, because I know that can get old. It's, again, that's part of the business, is finding parts, adding them to your part library, adding them to your MRP software, inventory management software, so you know what you've got to order and all that stuff. We'll get into that further as we get into the process of building up our work orders, our bombs, and everything else, which we are close to doing. So since I've already got that in here, so the chip I found was just a slight variation on the exact same one that we had already chosen. I think DigiKey may actually have these in stock, so I'm not terribly worried about them. Yeah, so DigiKey's got them, comparable price. When it comes time to actually build our bombs and do our orders, we'll fix things and fix vendors and stuff, so I'm not terribly worried about that. So how you would handle something like that in, like, say, KiCad? Let's just run through it real quick. I don't want to leave. So the reason I do this, manufacturer 1, vendor A1, all that. So let's go ahead and add vendor 1B. So this is a B vendor, an alternative vendor to that manufacturer 1 part number. So we're going to put DigiKey, vendor 1B part number. And we're going to go to DigiKeys. Now, okay, so DigiKey prefers you if you use their right part number when you're ordering something. So they've kind of got it organized. A lot of times you'll see cut tape, CT. That's when you're ordering below real quantities and you just want them on the cut tape. If you don't know what that is, we'll get into more details in the further stream when we actually go to order part, or, well, receive the parts into our inventory system and, labeling and things. I'll show you. We'll get better pictures and better references. I am, getting a webcam so we can have, more video feedback. I'll be doing some testing. Who knows? Maybe I'll try doing some streaming with it. I don't know, but definitely during the building phase and maybe some of the other later parts, we'll kind of utilize it to help showcase some stuff. So, they would prefer if you use this part number for cut tape orders. DigiReel is if you order, let's say, half of a reel, like in this case, a reel is 2,500. So let's say you want to order 1,000 parts, but you want it to be on a reel so you can throw it into a pick and place machine, or better organization, depending on how you really want to do it. That would be called a they call it their digi reel. Mauser has their own kind of service which does the same thing, but they all come with a surcharge. So if you want that part on a reel for a pick and place machine, they charge an additional $7. So you got to order the $1,000. I mean, 1,000 parts, my bad, which is $395.07. And then if you want that on a reel provided by them, that's an additional $7. Now, you could be enterprising later on with a business and just save empty reels that you can pull the labels off of easily, and you can just relabel reels. They're all standard sizes, and we'll get into that down the road when we go to receive parts and do the building and stuff. And then TNR is typically the part number they want you to use if you're ordering a full reel. That's pretty much their part number breakdown structure. A lot of times if it just helps them clarify stuff. If you order like a real quantity, like 2,500 parts, but with this part number, their system is smart enough to know you want tape and reel. So we're just going to go and choose cut tape. We can put in Odo that part number for the quantity ordering so it knows better. But that, again, down the road, I'm not going to be overly concerned about that. So we're going to put that part number in there. So that's DigiKey's part. Vendor 1B, cost low volume, and vendor 1B, high volume. So let's get again, I consider high volume at 1,000 quantity, so it's 81 cents and 395.07. Jeez. 81 and 395.07. I've already forgotten that number. You know what? Let's just copy that number and just remember 81 cents for the other one. Short-term memory, just bleh. Plus there's so many things going on. So what that does then is we could just kind of push this down at the bottom. Boom. So now that's how we would enter an alternative vendor for that part for manufacturer one part number. Now, there are other manufacturers that would more likely make this part with the same specs and fit in the same footprint. And that would be a whole other section like manufacturer two part number, vendor 2A could still be Mauser, but it could have the part number for that part. That's how the logic flows with this. So it's consistent across the board. And when you look at it, you understand what you're looking at. So we're going to put that in there. So we'll throw that in there. So we're going to save that, and we're going to go to our schematic. And we're going to go ahead and drop that in. All right, components. 3 okay. Again, it's the exact same. We're going to go ahead and change that designator to IC4. It may complain about it, but it don't matter because what we're going to do is we're going to pop this guy out, put this guy right in his place, plumb it up, get rid of the 5-volt supply. So let's go over here and grab 3.3. Go back over to here. Bam. So now we have a 3.3 volt operating RS-45 transceiver, half duplex. Dropped in, part number, everything's the same. We won't have to worry about moving around the board or any traces we've already placed. Everything should just pop into place. Hopefully, sometimes the CAD software gets a little upset, but we haven't wired every single trace in. It's not like we can't go back and fix it. So let's go to the ESP32. Well, let's go ahead and grab one of these TVS diodes. Copy it, go to ESP32 because we're going to use it, but we're going to drop in. I went ahead and got the part number for a 6-pin header. That's it right there. So that'll be the 6-pin header. And then hit the X key to rotate it on the X axis. Just kind of make things a little neater. We're going to kind of put this guy down here. Now, so we're not going to be porting these over across the sheet. So let's go ahead and give them nut labels. It's going to be UART RX. And UART TX. And what we can do is just get rid of that port, get rid of that port. Okay, that gets annoying when that little stuff happens, but let's go ahead and move forward. Hello. All right, let's move forward. There we go. All right, where style. TX. All right. Boom. Now, one of the things we want to keep in mind is that, so I need a ground, let's grab that. Okay. So it's FTDI, so I went ahead and pulled up an image for a pinout. So, this is your typical pinout for a USB to FT, basically USB to serial breakout FTDI adapter, as it's typically called. Technically, it's USB to serial RS-232 UART adapter. FTDI just happens to be a very common, popular brand manufacturer for the maker of the actual interface IC. It could be Silicon Labs, could be any of those other companies. Basically, a USB to UART bridge chip. That's basically all it is. FTDI just happens to be one of the big companies in the game, and a lot of the USB adapter cables and devices are built on the FTDI chips. So we're just going to go with the typical pinout, pin 1 being ground. So back in our schematic, for the sake of readability, we're going to flip this on the Y-axis as well to bring pin 1 down to the bottom, because it's going to tie to the ground pin. All right, so we need pin 4 and 5 pulled out. Oh, what did I do that for? I'm an idiot. Pin 4 and 5 pulled out. Same cable, just a different picture, because I was an idiot and closed out the drawing. So we need pins 4 and 5 pulled out. And then let's go and throw DNC connectors on these guys. They aren't used. Now, we have to not label those guys. Now, pin 4. Well, let's go with pin 5 because it's at top. It's RXD. But with UART, we know we want to make sure I got that right. Pin 5 is RXD, so you want TX. And then, so pin 4 will say TX, but over here it's going to be RX. So with typical serial, especially for 232, you swap the transmit and receive pairs when you're going from one device to the other. You basically cross them over. So let's just double check. Pin 5 on the pinout is RX, but it needs to be TX. Pin 4 is TX, but it should be RX. That way we have the crossover. it's gonna you have to have it somewhere for it to operate properly. So we're gonna do it there. You know, and to kind of tidy this up, make it look a little prettier, just cause. Put the ground in there. Oop. Hang you there. And boom. So that's a TVS diode. That's, again, that'll help mitigate any transient voltage spikes due to human contact as you're plugging the cable in, to limit any damage to the ESP32. So we got those changes made. So I've got the PCB open over here. So we're going to, so this IC will change. Hopefully none of the traces break and it doesn't get flown all over the place. That's why I kept the name the same. So I made sure I labeled IC4, but you never know. Tools, update PCB from schematic. Boom. Close. All right. So those are the parts I got added. That go on the back side. Right off the bat. This guy. Fix the text. Wish I would have defaulted at that. I know there's a way you can do them all at once, but there's only 3 that we have to fix. And I got the step file for that in the proper location. So let's see here. Now let's go to 88. Let's see. Let's look how the ground port's looking. Let's look. Okay, everything looks good. Let's kind of pull that back a bit. It's 97.5. Nope. 98, probably it. Pull this guy down a little bit. Refilling any. Nope. Okay. Okay. We should be good. We should be good. All right. Oh, yes. So, good. We need to fix this. So let's get rid of this. Do not need this 5-volt trace in here anymore. It's a shame we couldn't have found a fan. We don't need these vias in here anymore either. Fill in all those guys. Come back over here. Zone. Let's get us 3v3. Boom. And put these guys on 3v3. Cause it was kind of cool. We'll refill all that. All right. Now because these are 3v3, you kind of clean this up a little bit. Drop that in a little bit there. Boom. All right. Perfect. Now our RS485 transceiver is dropped into place. Everything looks like it's fine. Good, good, good. Now we'll come over here. Again, this is for the ESP32. I will throw this guy on the bottom. Why not? and we'll get that plumbed in. So now that we know we need that, and we should be good to go to continue on our layout spree. So these guys are part of the auto program, which kind of takes direct route over here. I mean, except for boot mode, which is right there. So no matter how we slice it and dice it, there's going to be a kind of a fight on stuff. So I'm not terribly worried about how we do things. It's still going to be running traces and getting things tied in. But we'll get things as close as possible and as neatly as possible. So let's start with the main transistor. We'll keep it there, 21, and we'll keep that there. We'll pull you around here for now. Remember, that's on the bottom, so it's not going to be affecting that silk screen. What's your... We'll go to the bottom copper, make sure we'll see what we're doing. 21. 21. 80.5. Let's go ahead and move you out of the way for now. 74. We can probably squeeze you a little closer, 74.5. All right. We'll probably do you up here. There we go. So that kind of starts plumbing in the auto program stuff. So let's go ahead and start seeing what we can route. If I select the right thing. All right. DTR. All right. So these are going to get a little crazy. Can't keep moved. Is there enough room to bring this trace up out of here? Okay, okay. Go ahead and pull you up here. Okay, got that via there. Now we have boot mode. Bottom copper. Okay, so we have some test points. We'll worry about them in a minute. I want to get everything routed to over to the UART bridge, and where else we need to go from there. So we have our DTR, and RTS that needs to go over here. So let's start with the RTS. All right. So then let's go to the top. So we have a few things we need to make sure we can escape from here. DTR is one of them. So what we might be able to do, yeah, I call it escape. It's just the term I use. No, it makes no difference to me what term you want to use. I just call it escape. Excuse me. Okay. So DTR right there. All right. So what we can do, pull that a little bit further over here. So the other two things we need to escape are the TX and the RX lines for here. So we can do, grab the VIA. We're going to make a few things mad, but that's okay. It's nothing we can't fix. Yeah. All right. There we go. Just kind of drag and drop them in a better place. That'll just make it easier to escape these two guys over to the ESP32. Maybe we ought to go and start working on that. Let's go and do that. Because then that'll plumb up this guy's signal logic. Never hurts to start banging some of these guys out and getting things done. All right, I'll make sure we don't jam up the works and not give this guy a way out. You always want to make sure you give your signals a path to go. Okay, so let's drop you on the bottom. Hello. You should have given me a VIA. There we go. On the bottom. Copper. Why in the world you got to be such a stubborn tool? Boom. All right. Now, why you want to be so stubborn? I didn't want to go there, you gooby. Didn't want want to go there. Why are you doing this to me? Bottom copper. Ugh. And plus. Oh. What in the world? Why are you playing these bad games with me? Here. There. There's the via. Jeez Louise. Okay. Stubborn old fool. Some people say about me, it's just a stubborn old fool. All right. So. What's funny is boot mode's over here. So what we're going to do, we're going to drag this guy over here, drag this guy over here, pull this guy over here, and what I'm going to do is I'm going to put him on the bottom. Bottom, backside. Because why not? Because then I can throw him like right in here. Or even right up here. Or even right here. Let's go and do that. Let's throw him right there. And if you're asking if there's any scientific method or methodology that I'm using to do, no. Sometimes it's just, we're just going by feel. For a lot of components, that have no specific layout requirements, trace requirements like high speed, memory buses or anything. A lot of times it just goes by feel. There's really no way. There's no reason or rhyme to follow any specific pattern. And since that's up there, let's do this. 57. I'll push you right here. Not a big deal. This guy's going to be over here. I think I said 4. 73, and I've learned from experience, you don't want these guys like right butt up against each other. You want some room between them. There we go. Because if you're trying to fumble them, they're not very large push buttons. And if you're trying to fumble and do your boot and your mode to, if you've got a program issue with the USB or whatever, it's not communicating properly or programming properly. Trying to fumble with these buttons when they're too close together is a pain in the rear. So if you've got the room to space them out. We're just gonna go ahead and move them to 80. Give yourself the room. Don't give yourself the headache. I learned the hard way. All right, so this guy can go like this. We'll diode in between. You could put it on the bottom, but no real reason to. What the heck? Let's just stay with that motif. Let's move the diode. Move that guy right there. Actually, right up here, because... Okay, so we got this tied in together. All right, so let's go ahead and start plugging and chugging these guys together. There's that. I mean, it's a button. You don't really need a nice ground pour, but you know what? Let's do it. Let's just give this guy a nice little ground pour. Because I feel saucy. Why not? And at the end of the day, too, it'll give your switch's poor little lead something nice and solid to hold on to at the end of the day. It'd be less likely to just snap off. All right, so we want to go get some. Although we don't need them, but let's just do it. If we're gonna do it, let's just do it right. Let's give this guy some chunky power vias. Again, it's a push button switch. You don't need to, but you know, for the sake of consistency, let's just go ahead and do it. Give this guy these chunky power vias. A little angled off. Fill that in. Great. Now we're going to go and throw text in. Let's go ahead. And that is, we're going to call that boot. Boot. All right. 655. All right. That looks pretty darn good to me. Now let's go ahead and route this guy in. Come over here. Okay. And let's go ahead. I put that in the wrong layer, didn't I? There. Easy as just changing the right layer. I was on the bottom. Didn't even realize it. Thanks for catching that, chat. Oh, there's nobody in chat. Oh, there is somebody in chat. Hello, welcome. Yes, I'm human. I make mistakes. Let's drop this guy down. There we go. Yeah. Again, you don't need these chunky power vias there. It's just a ground reference for the switch. But why not? Let's stay consistent with our design. Now for the TVS diode. If you haven't been following the video, thanks for checking in. So this is a long-term video series I call From Breadboard to Market, where I'm taking a concept of a project that I laid out on a breadboard, and I'm going through the full process of actually designing it, gathering the schematics, using KiCad, doing the PCB board layout. We're going to be doing videos on the actual, ordering the parts, getting them in inventory. We're trying to cover the whole gambit as much as possible, with the premise that you're a hobbyist wanting to venture forward and take your design into the actual market, like sell online, sell on Amazon or Etsy or eBay, or even through your own shop, because there's a lot of pitfalls and a lot of things you can run into that are gotchas, and I'm trying to cover all that through my years of experience, things that you need to be mindful of. And also we're using KiCad to give those new to the space just some experience and some grounds to kind of understand what they're doing, just a foothold, so you're not flailing blindly trying to design or put your idea from a breadboard concept, like using an Arduino or something, or an ESP32 dev kit, and actually making an actual board, a physical board out of it. So you're pretty much caught up with you're on episode 22 right now, essentially a video stream at 22. I don't know if I have my YouTube link in my Twitch. If it's not, I'll try getting it on there. But I have a YouTube channel where all the actual videos are posted. So if you are really interested in this, really curious, definitely come check out start episode 1, because it really lays out the project. I'm trying to also cover the gambit of project management, quality management systems such as ISO 9001. Just using my experience and background in that just to help push the learning process along. So there's less surprises if anybody's interested in actually trying to make a business out of their ideas. So I'm also trying to teach some, good principles on layout, PCB layout, schematic capture and design, some things that could be good gotchas. So now we're over here. So now to kind of pick up where we were, which is no problem. I'm happy to explain anything to anybody watching or any questions you might have. I'll try to watch chat, but I tend to get really focused on what I'm doing. I just get lost in it. So now, since this guy is a really functional device that serves to send any like static shock. Like if you walk across carpet and you touch one of these switches, you could send a jolt of electricity to the ESP32 and destroy it. That's what this guy does. It's what's called a transient voltage suppressor. It's a special diode designed to take that extra voltage and sync it to the ground plane in an attempt to protect the rest of the circuitry. It's always good practice to throw TVS onto anything that humans have contact, humans can contact during the normal operation, testing, or development phase. So if you've got a switch or a button, you definitely want to try putting a TVS diode on it, especially if it directly interfaces with a microcontroller like an ESP32. USB connector, I've got a couple of TVS diodes over here protecting some of the input circuitry. The RS485, since a human can touch these inputs, I've got TVS, so it's just a common practice. And then the FTDI cable interface, I've got another TVS diode, because humans, again, will be touching that and they can send in a shock, which can damage components. Not to say you don't want to go too crazy and put TVS on everything, but the most common parts where humans are more likely to touch that directly interface with more sensitive components, such as microcontrollers or more sensitive interface chips like USB to UART chips. So since this protects this, we're going to definitely make sure we put a good solid ground plane in. We want to make sure that we sync any of this extra voltage down to the ground plane. So we're going to just start by drawing our polygon. We'll fix it as necessary, but this gets the snapping the grid gets annoying. So we're going to grab that. I didn't double click. So let me copy this via. Again, I kind of went nuts on this switch, putting that big ground plane in, but at the same time, it takes these 4 pins on a tiny little push button switch and it gives us something more solid to grab onto instead of these little pads, which can be broken off easier. So at the end of the day, it could be beneficial. So we're going to try to stick with at least 3 power vias to make sure we have a good connection to the ground plane here. Fill that in, see what it looks like, make sure it looks okay. That looks delicious. So we're going to rotate this guy to make sure this is up. All right, kind of match this. Yeah, and if you've ever used KiCad, I will make mistakes. Don't be afraid to point them out, but be respectful about it. KiCad's not the program I typically use. All right, so let's go ahead and on the ground plane here for these guys. Again, don't need it, but could be beneficial for this little switch to help hold it in place. Oh no, you didn't snap where I needed you to. That's fine. You didn't explode on me, so you're all right. Should have the vias still in my copy paste buffer, so put you in here. Okay, B. Looks like it maintained my settings from the last time. Okay, good. You know what? Let's go ahead. Let me clean this up here. You know what? I want this to be a little bit bigger. So I'm going to give it 2.54, make it a little bit bigger because of the critical role it plays. We're going to kind of pull this guy out of here. All right. Fix that here in a minute. Again, there are rules that you could set where it could define via or trace widths by net class, but sometimes it becomes more of a pain than it's worth. These guys together. Okay, so that's ESP enable, which goes all the way up to here, which we can just connect off of this guy. How hard would that be to get up there? Not very difficult. What we're going to do is we're going to kind of route up. And we're going to drop down. Bottom layer. Why aren't you switching the bottom layer on? You were... Oh, okay. You know what? That's a push button. That's going to be a tangled mess of crying and sadness. What we're going to do is we're going to bring that through our north-south routing layer, which is going to be the internal signal layer number 2. And we're just going to tie it to the via. Because again, that's a button for manual control. All right. So we're getting a lot of the logic plumbed in as we go. All right. Okay, so that's for that's for the fault. We can throw that on the bottom and put that up underneath the ESP32. Punch your numbers. That looks good. All right. Nomenclature going. Route in here. Via to the top layer. Boom. There we go. And pop you in just a 3.3 volt plane. Don't matter where that goes, what layer, because it's going to be a through-hole via anyway. All right. So that's for the step, basically the stepper driver chip fault indicator. These guys, I might be able to kind of flood in around there, but let's get the critical parts. To be honest, if the test points don't look like they're going to fit right, I'm not going to cry if we have to lose them. But I think we'll be okay. I think we'll be fine. All right. Step reset. You know what? I could technically go on the bottom too. Let's go to 24. 24.5. That looks better. That looks good there. And top layer. And put you into the 3v3. There we go. actually kind of go on the bottom too. All right, 16. And that works. That resistor in place. Top. Boom. All right. Good. Hello. There we go. Just a pull-up resistor, so I'm not too terribly worried about how strong the I'm not looking at power plane via for that. All right, okay, we got a lot of these guys. Now a lot of it's going to be getting our signals routed in. I don't know about you, but I don't like crowding out my components with other components. So kind of like leave your RX TX. It's all the way down here. So we don't have, no, we're gonna have a lot of traffic going left and right. Like that being too far away from there. Pin 1. That might be okay. Because a lot of this traffic is going to come from these guys and it can go on inner planes if necessary. Let's go ahead and do that. 50 and 27. But what we can do is go to the top. And we're going to take a look at the 3D view. This is what's great about the 3D view of the board. So I don't like how it's too close to this guy. We do have some wiggle room to move a little closer to ESP32. Because the way it's laid out, the antenna, the IPX antenna is going to be connected over here. This won't be in the way of it. So we can snug it a little closer to the ESP32. We can also move it up a little bit to make sure we have enough clearance on this guy, because this is going to be for our fan connector. And then this is the TVS diode. That's going to be protecting these guys. Can really go anywhere. So one of the things I want to do is grab that text. Oh yeah, before I forget, we're going to drop this in here and we're going to name it enable. 6 and 78. Let's see how that looks. How about 77? Looks good enough for me. It looks like a winner there. And then we're gonna Control V. FTDI. Actually, what we can do is we can call it debug. Debug interface. So let's go. Yeah, let's do that. Let's go to 16. Let's 16.5. Double click. That looks good to me. Move this guy into place. Let's see, 47. Kind of don't like how the ground is there. That would cross that over. That works a little bit better. Let's bring it down. RX and TX. Oh, let's bring it up then. Bring it above. That doesn't work either. My goodness. Trying to avoid throwing a V on there. All right, I know what we can do. Let's not fret over small details. Let's just do it this way. All right, let's just leave that guy well enough alone. Go to the bottom copper. Can make that guy a little beefier. That guy a little beefier. Let's just do this. Ground. Not the most pleasant to look at, but you know what? We're not looking for art here. We're not making art. We're making circuits. We're making boards. And if nobody likes my baked boards, well, I don't care. Stop. There we go. And right now, let's grab one of these nice big ground videos. All right. I think that will do it. That'll do, little Via. That'll do. Fill you in. Now that's sexy. That'll work. Okay. So now I guess it's the really last act of items we can kind of really plumb in before we really start seriously plumbing down all of our signal vias, or our signal lines, my bad. Is the fan connector. So I'm not too unhappy with it here. Let's see how that looks. Probably nudge it over this way, X by millimeter. Let's see, let's get an idea of the 3D view. Just trying to get an idea how much of a pain it will be to plug in a cable, a connector into here, because we need, not terribly bad. And that's just for a fan for active cooling to help keep this guy cool. Now we could move it up here. Could. I mean, there's more than enough physical room to move it up here. More than enough. We can put that guy there. The tack pull-up resistor. You can honestly put it on the bottom of the board, or it could just kind of sit back here, which would be fine either way. Let's just kind of take a gander at the 3D view. Would be more acceptable, I think. Maybe we can push a little further up and over this way, a hair by these test points. Put the resistor, so let's kind of move you up a little bit further. Because I also want to make sure I don't interfere with the heat sink that's going to be strapped to that guy. Right? You know what? That'll work. 75, 74. That works there. That's 70. That's 78. Let's move the designator there. All right. Five and six, they're part of the metal housing. And they're not tied to anything like ground or anything. They're big pads. I wonder if we could... I could assign them to ground. You know what? Let's do that. They don't need to be tied to ground. Something's telling me, mainly because I want to be able to give them a really nice ground port to really give this board, this connector, something to hold on to when it's soldered. Because remember, you're going to be bringing the connector in from this angle to plug it in. And the force is you're only going to have these two little tiny pads to hold back that kind of force. So if we tie these little metal tabs on each side, the mounting stakes basically, to ground, we'll be able to much easier put a big old copper pour in here and grab them, and that way it gives them more surface area to hold on to. So, yeah, let's just do that. I'd rather have that and deal with that down the road than break these guys breaking off because they had nothing really holding them in place. It's much easier just to do things like this. You know, we got the room. Let's just go ahead and give this guy a big old ground. All right. Vias and tracks. Okay. Okay. That looks good. Grab that via, those big ground vias that I like to use. Don't necessarily need them around this guy because that's not where your power is. Your power is right here. Your actual ground connection's right here. Doesn't hurt to have a few in here. Just to help stitch this plane, you know, to ground. Never hurts. Is it necessary? I'd say not really. Right. I'm going to try pushing. Let's try pushing you over. About 70.25. That'll work. Okay, and again, that's just a 3.3 volt. That's just a pull up. So basically every tack pulse will be a low. It'll be a low. It'll be a low. So That's what the ESP is going to be counting, are the low pulses. I've already got a library driven or written for the ESP32 for a PWM controlled fan with a tach. You can control its speed and read the tach and everything from it. So I've already got one written that will just drop in for the ESP32. So now I have the 5 volt, which just kind of works out perfectly because we can kind of sneak up and all around there with a nice big heavy trace. So let's come off of this guy. Now, let's give this guy a nice big. But for consistency, let's just double check. Open the operational block diagram. Copy this part number. And we're going to go to Mausa. Data sheet. And we're going to see what its expected current draw is. Input current. So it's a 5 volt model, 240 milliamps, so 250 milliamps. So we're barely scratching the surface. We're barely drawing any power. We're not even at a quarter watt. So this trace size should be more than capable of handling that. All right, so there's that. 5 volt to the fan. All right, we are making progress. We are getting things plugged and chugged. Now it's just a matter of untangling this mess and figuring out what direction to take things in. These test points we can start putting in too if we really wanted them. Boot mode. Technically, we could kind of pull off of here as well. Pull off of that one. I would like to kind of keep them somewhat close together, clustered in a way that makes sense. And we'll have a ground down here that we can always use as the reference. So let's see here. Don't want that too close to any of those traces. Boot mode. RTS. Data terminal ready. And enable. Push you up there, push you over here. Right, let's kind of clean you up a little bit. 86 and 15 is fine. Do that. Let's do. Get you guys lined up at least on that axis. And these shouldn't be in the way of the IPX antenna. They're not very high profile, so that should be fine there. Text. There we go. All right, so we can nudge you down a little bit. 20. Yeah, that works. You should be pretty good. Let's see how you're doing. 30. All right. That actually looks okay. Let's go to the 3D view. Yeah, we should have plenty of room to tie an IPX antenna to the ESP32 with those test points. Again, we don't have to populate them with these. We just leave them as holes and tie into them. That way nothing interferes. We could just populate test points on like the first small batch of boards we build for our initial testing, basically our qualification testing. We can leave it at that and then not populate them in the actual release version. For one thing, it'll save money and other things. Reduce the complications of the build because they are through hole parts. So that's what we can do. So for now, we'll plan on populating for the first few test batches, but after that, it's going to be only not populated and release because we won't need them. They're just for even the debug interface may not be populated and release. Who knows? That's the great thing about it is we can not populate the debug, but we'll just probably leave the debug because this will be kind of an open kit. Test points we probably won't populate. I don't know yet. It's a decision I haven't completely made yet, but we'll go from there. We'll process that. We'll cross that bridge when we get there. So let's try to plumb up these guys at least before before I end the video. There we go. RTS. Now ESP enable. I think it's that. So that's what's kind of cool. These are just test points. They're not like super mission critical. Top layer. There we go. Perfect. We're not going to change the name of these test points or put labels. We'll have documentation that covers all that. So that plumbs in quite a few of the supporting components and systems. Now the really complicated layout's going to come in to basically bring all the inputs in, tie them to the ESP32, the drive out, the control outputs and inputs to the stepper controller and the RS-45 interface. Cool thing is we got the UART programming interface already plumbed in. So it's just going to be spaghetti haven. That's why we've got a 6-layer board. So we have a total 4 signal layers to handle this routing on. All right, and that's where I'm going to end the video and end the stream. We've made quite a bit of... Thank you. Thank you. I appreciate you checking out the video and following along. Almost done. Hopefully maybe 2 more videos, 2 more streams, and we'll have it all plumbed together. The real hard work's going to come in routing all these signal control lines. That's where the rat's nest and the headaches really begin. But like I said, we have 4 total signal layers we can route in between. I try as a rule and through general practice, try to maximize my vias used to only 2 per signal line. Basically 1 going into a layer or wherever you need to go and 1 coming back out to the actual connection you're trying to make. As a general rule, I try to stick with it. Sometimes it's unavoidable to add more vias, but honestly, with 4 signal layers, there should be no problem. It's going to be interesting. It's going to be fun. It's going to be a headache, but we'll get there. I thank everybody for watching and checking us out. I'll have this edited and uploaded on YouTube. I don't know when. I was originally going to just do 1 video every Friday, but then I was thinking about it, like, with all the other videos I want to make and that I hope others are finding this content really interesting. I want to get this out there in other people's hands as soon as possible, just to try to get that knowledge out there. So I'm going to try to get this edited and uploaded hopefully by the end of this weekend, along with the other ones that I have. So thanks again. Have a nice evening.